Welcome to Day 10, the final module of the KMC Technologies Group Microsoft Copilot Studio Implementation course. Over the previous 9 days, we built knowledge, topics, tools, security, orchestration, testing, and deployment. Today, we answer the question that determines whether an AI implementation actually succeeds in the enterprise. How do we operate it reliably after launch? We'll transform our completed agent from a successful implementation project into a maintainable production service. Today, we bring together everything from the course. We'll define production support ownership. We'll establish operational KPIs and monitoring. We'll review capacity, quotas, connectors, and back-end dependencies. We'll introduce model lifecycle management. And we'll create processes for incidents, knowledge changes, and ongoing governance. Our final deliverables are the production architecture, readiness review, support matrix, operations runbook, final capstone demonstration, and a 30, 60, and 90-day improvement roadmap. This is the complete end-to-end architecture we have built. Employees enter through Teams or Microsoft 365 using authenticated identities. The KMC agent applies its instructions and orchestration rules. For policy and how-to questions, it retrieves information from approved enterprise knowledge. For transactional requests, it invokes controlled topics, tools, and agent flows. The ITSM backend stores and retrieves ticket information. And security incidents or other cases requiring human support are routed through an approved escalation path. Production reliability depends on every one of these layers working together. Before declaring the project complete, verify that every promised capability has an implementation, an owner, and operational evidence. The IT FAQ depends on approved knowledge and should be owned by the content owner. Create ticket and get ticket status depend on the ITSM or integration owner. Security escalation needs clear ownership by the security team. Human handoff belongs to the service desk operating model. And Teams or Microsoft 365 channel availability needs a platform owner. If a capability has no owner, it has no reliable production support model. Before production launch, conduct a formal readiness review. First, confirm scope. The audience, supported capabilities, exclusions, and escalation paths should all be documented. Second, confirm security. Authentication, DLP, least privilege, knowledge access, and tool authorization must pass. Third, confirm quality through regression, grounded answer testing, security testing, and channel UAT. Fourth, confirm ALM and rollback. Fifth, confirm operations, owners, support hours, monitoring, incident paths, and change processes. Finally, review capacity, quotas, connector limits, and growth assumptions. Do not launch while a blocking control remains unresolved. A production agent needs named ownership at every critical layer. The product or technical owner manages instructions, topics, routing behavior, and release decisions. The content owner manages knowledge accuracy, freshness, and permissions. The integration owner manages flows, connector authentication, and back-end availability. The security and identity owner manages authentication, DLP, access control, and threat response. The Microsoft 365 platform owner manages the channel availability and access. And the service desk owns the human support and escalation experience. Every primary owner should also have a backup. A useful production dashboard should measure both user value and operational risk. Track successful task completion. Measure grounded answer quality and routing accuracy. Monitor, create ticket, and get ticket. Status success rates. Measure median latency as well as slower tail latency. Track escalation rate and the reasons users escalate. Watch the no match and clarification rate. Security or unauthorized access failures should target 0. User satisfaction and repeated rephrasing provide additional signals. And regression trends show whether quality is improving or deteriorating across releases. Production operations become manageable when they follow a simple recurring cadence. Daily, review critical tool failures, outages, security events, and user-impacting incidents. Weekly, examine unanswered questions, no-match trends, escalation patterns, and knowledge problems. Before releases, rerun the regression pack and update the release documentation. Monthly, review permissions, connector health, capacity, usage, and content freshness. Quarterly, step back and reassess architecture, DLP, security, model choices, agent scope, and possible retirement candidates. An agent can appear healthy while one downstream dependency is approaching its limit. Monitor Copilot Studio usage and relevant generative limits. Monitor connector throttling. Track flow execution duration and failure rates. Monitor API, Dataverse, SharePoint, or ITSM capacity. Capacity planning should also consider peak concurrent users and burst traffic. For example, a major outage might generate hundreds of employee requests at once. Design timeout and retry behavior carefully. Provide graceful degradation when transactional systems are unavailable, and define alert thresholds and ownership. Production design should also consider graceful degradation. Suppose the ticketing connector is temporarily unavailable. The entire agent does not necessarily need to become unusable. Knowledge questions may still work. The agent can explain that ticket creation is temporarily unavailable. It can provide an approved human support path. The important principle is to fail safely and transparently without inventing success. Models are also production dependencies. Track which model the production agent currently uses. Monitor Microsoft announcements, availability changes, and model retirement timelines. Evaluate potential model changes in a non-production environment. Run the stable regression dataset before migration. After any model change, compare quality, latency, reliability, and consumption, and avoid making a production service dependent on preview or experimental models unless the organization has explicitly accepted that risk. When an agent fails in production, respond by layer instead of guessing. First, classify the incident. Is it knowledge, routing, tool execution, identity and security, channel behavior, or a platform dependency? Second, protect users. Disable a risky tool or route users to human support if necessary. Third, collect evidence such as agent version, conversation time, flow run ID, backend result, user identity context, and channel. Then mitigate. That might mean rollback, fixing a connection, restoring a source, adjusting routing, or providing a temporary workaround. After mitigation, run focused regression and critical security tests. Finally, add the incident scenario permanently to the regression set. Consider a real example. Employees suddenly report that ticket creation is failing. The operations team first confirms that knowledge responses continue to work, narrowing the incident to the transaction layer. Flow run evidence shows an authentication failure against the ticketing connector. The integration owner repairs the connection reference. A controlled test creates a ticket successfully. The team then runs the critical transaction and security regression cases before closing the incident. That is a structured operational response instead of trial and error troubleshooting. When an agent fails in production, respond by layer instead of guessing. First, classify the incident. Is it knowledge, routing, tool execution, identity and security, channel behavior, or a platform dependency? Second, protect users. Disable a risky tool or route users to human support if necessary. Third, collect evidence such as agent version, conversation time, flow run ID, backend result, user identity context, and channel. Then mitigate. That might mean rollback, fixing a connection, restoring a source, adjusting routing, or providing a temporary workaround. After mitigation, run focused regression and critical security tests. Finally, add the incident scenario permanently to the regression set. Now we perform the final capstone acceptance demonstration. First, the user asks a VPN policy question. The expected behavior is a concise answer grounded in the approved knowledge source. The evidence is the source-aligned response. No ticket should be created because this is an information request. Second, the user reports an Outlook crash. The agent enters the structured support ticket topic and collects any missing information. The captured variables are displayed back for confirmation. Only after confirmation does Create Ticket execute. The flow should run exactly once. The acceptance evidence is both the return ticket identifier and the backend or flow run record. Third, the user asks for the status of the newly created ticket. The orchestrator should choose Get Ticket Status rather than creating a duplicate ticket. The tool performs an authorized lookup and returns the current safe ticket information. The acceptance evidence is the authorized current status. Fourth, test the highest risk path. The user reports clicking a phishing link. The agent should route to the approved security escalation path. It should not ask the user to provide their password. It should not run lengthy generic troubleshooting. The acceptance evidence is deterministic escalation with no unsafe advice. Finally, ask for a human. The agent should honor the request and enter the configured handoff or approved support contact path. Where live transfer is available, preserve useful safe context. The proof that the capstone is complete is not simply a message saying escalation occurred. The configured human support path must actually be reachable. All of this operating knowledge needs to live in a production runbook. The runbook should document the agent's purpose, audience, owner, channels, and exclusions. Describe the environment and solution architecture. Document knowledge sources, ownership, permissions, and review cadence. List tools, flows, connector ownership, contracts, and backend dependencies. Document authentication, Entra identity, DLP, and least privilege. Include release procedures, versioning, rollback, and emergency disable steps. Define monitoring, alert thresholds, incident response, and escalation contacts, and maintain the regression and security test sets alongside the operating model. After launch, resist the temptation to expand immediately. The first 30 days should focus on stability. Monitor quality and connector reliability. Identify repeated unanswered questions. Observe real routing behavior. Improve knowledge hygiene. Track ticket deflection and escalation. The goal is to understand how employees actually use the agent before adding more complexity. Between 30 and 60 days, use production data to tune the service. Improve routing based on real user prompts. Resolve the highest impact knowledge gaps. Strengthen connector reliability. Review recurring escalations. Continue updating the regression dataset with newly discovered behavior. By this stage, production evidence should drive improvement decisions rather than assumptions. By 90 days, the organization should have enough operational evidence to consider expansion. You may introduce additional approved tools. Automate more of the evaluation process. Expand to additional channels if users need them. Assess whether specialized or multi-agent domains are now justified. Review capacity and model choices. And evaluate business impact. The roadmap should expand from proven usage patterns, not simply from available platform features. At this point, review the complete course implementation. You should have a governed development, test, and production strategy, solution packaging and versioning, agent instructions and guardrails, approved knowledge grounding, structured ticket topics and variables, create ticket and get ticket, status capabilities, Entra authentication and DLP, generative orchestration and human escalation, regression, security, and user acceptance testing, Teams or Microsoft 365 deployment, a production operations runbook, and an ongoing monitoring and model lifecycle plan. One final principle summarizes the entire course. The implementation is not complete simply because it works in the maker test pane. It is complete when a standard end user can use the production intended channel with the correct identity, retrieve approved information, execute authorized tools, receive safe escalation, and successfully complete the intended business process. That is the real definition of production readiness. Across this course, we moved step by step from a blank environment to a complete production operating model. We established the platform foundation. We configured agent behavior. We introduced trusted enterprise knowledge. We created structured conversations. We connected tools and flows. We secured identity, data, and actions. We built orchestration and escalation. We established repeatable quality engineering. We implemented deployment and ALM. And today we completed production operations. Together, these layers form the implementation blueprint for an enterprise Copilot Studio agent. The next step is practical. Reproduce this capstone in your own tenant using your organization's approved IT knowledge, ticketing platform, identity controls, and target channels. Then run the same final end-to-end demo as acceptance testing. Use Microsoft's current documentation as the source of truth for platform settings and capabilities as the product evolves. Utilize Microsoft Learn as a resource for further implementation steps and references. This ensures your deployment aligns with best practices and industry standards. Congratulations! You have completed the KMC Technologies Group Microsoft Copilot Studio Implementation course. You now have an end-to-end blueprint covering architecture, knowledge, conversation design, tools, security, orchestration, testing, deployment, and production operations. The goal is no longer simply to build an AI agent. The goal is to operate a secure, measurable, governed, and valuable enterprise service. Thank you for learning with KMC Technologies Group.